want to thank the MLOps community. It's a great community in general, and it's nice to be able to host a workshop in collaboration with them. And today the workshop is going to be kind of two parts. We're going to be talking about a number of challenges in modern machine learning, and then specifically in kind of a business environment. And I'll introduce myself quickly. I'm going to discuss a case that we'll be using mostly in the second part of the workshop. Then we'll talk about deployment, reproducibility, and automation. And then I kind of want to touch upon a number of things. It's kind of, what is it? Why is it important? What is kind of the current status quo? How do organizations deal with this? And what do I think the future will look like? Where are we going as kind of in the MLOps world? And then the second part will be, we're going to use this case inside Cubonacci, and I'm going to use that case to show how we approach these challenges. And also I will showcase or explain how I think in the future that will look like inside the Cubonacci. So my name is Jan van der Vecht. So that's I'm Dutch, as you might expect from the name. And before founding Cubonacci, I worked as a data scientist at a big airline here in the Netherlands. And I got more and more involved into the MLOps side and the engineering side of things because I was a bit frustrated with how difficult it was and the broad range of skill sets required to be able to do machine learning at scale in large organizations. So that's why we kind of came up with Cubonacci. Our vision is really about the full life cycle of machine learning projects. So starting from the ideation, then going to developing an initial model, getting that to production, kind of maintenance, keeping like iterating over your solution until eventual succession by a new model. And I think in a lot of cases, it's good to think about this upfront, because I believe strongly that by taking all these steps into consideration, you greatly increase the probability of success. So for this case, it's a pretty famous small data set. It's called the German credit data set. And the idea is that you have a number of features that say something about the loan application. So it's about how much does this person actually want a loan? How long will this loan be? What is the purpose? Certain personal circumstances, credit history, savings and checkings, and kind of property. And based on that, you want to be able to say whether this is a good credit or not a good credit. And in reality, maybe in the extreme cases where it's very obvious one way or the other, you would then automatically approve it. And in the case a bit more in the middle, maybe you would send it to a human that will evaluate the case. So you can already set it up now, because the idea is that if you want, you can follow along in our platform. So you can go to cloud.cubonacci.com. You can sign up for free with a GitHub account. You have to give a little bit of permission for us to get your name and your email. And then you can, inside Cubonacci, you can create a project. You can then add a repository and choose to create a new one in GitHub. And then you have to link that using the button and give it a little bit more specifically for that repository. And then from there you can, well, you have an empty repository. You can then choose to push something there, or in this case, it's easiest if you click the example projects, and then we'll kind of make a first commit with this German credit score task.
And Jan, is the idea kind of in the workshop that they would go do this right now, and then they could work alongside of you, or what's the?
Yeah. So. Yeah. No. So
yeah,
you can do it now, and then you can follow along during the second part, or you can do it during the second part, or you can just watch while I'm explaining things. But I think there's some benefit to signing up and following along, because it will give you maybe a better feel of how we tackle these challenges. Yeah, so whatever you want. So yeah, so now
can you go back to that for one more second? I'm gonna just write that down and I'll post it in the in the chat here. Okay, I've got it.
All right. So now we're going to talk about the three topics, and I would like to take a little bit a moment after each topic to see if there's any questions or remarks about the topic. So the first topic of today is going to be deployment. So what is deployment? It's a bit of a wide topic, but in general, it deals with, okay, you have a model that has been trained one way or the other, and in some automated fashion, you don't want to kind of use predictions from that model to inform people or to automate business processes, things like that. And that can have multiple forms from a more technical perspective. It can be request-based, so using some API. It could be batch-based, maybe every day or every week, or every time there's a new batch available, pull that data, feed it to the model, and then save those predictions somewhere. Or it could be streaming, which is using some kind of Kafka or RabbitMQ service where data is being pushed to, and the model will kind of consume that and store predictions somewhere. Yeah, and why do we want to do that? Well, in a lot of cases, we're not talking about ad hoc analysis, but with machine learning models, you want to optimize something, and the moment that you can deploy something and integrate it with other systems, that's the moment when you can actually start generating value, right? So that's the moment where you capture the value created by the initial time and money investment into this model. And of course, there's cases where even though there might be the intention to go to deployments, maybe the results are not good enough or whatever, but this is usually the moment when you start capturing that value. So what does that look like? I'm going to focus a little bit more on the request-based pattern, because that's the most frequent one with companies that we talk to and that we work with. And what it basically comes down to, after training a model, this trained model is serialized some way and then imported somewhere and being served. So this could be pickled, it could be using some kind of like standardized format like ONNX. And then you have to serve that out somehow, and that can be using Docker kind of to have a standardized environment to deal with this. Then kind of the next step is there's a number of serving platforms. So there's TensorFlow serving, there's Seldon, Kubeflow has a whole serving layer in there, and these kind of take this serialized form of a model and expose that as an API or maybe as a scheduled batch process or whatever, and allow you or allow other stakeholders, other programs, downstream tasks to connect to your model and and make decisions on that or give information to users on the front end. So then if you look at vendors, so there's of course commercial and also open source vendors that help companies and organizations and teams to deal with this. There's two approaches that you see. So the one which is more closely related to the serving platforms is you have some artifact that encapsulates the trained model, and you upload that to the vendor, and they deploy it for you, manage that for you, etc. An example of that is Algorithmia. They do it like that. And the other very different approach is if you have a platform that also deals with training your models and doing the experiments. That means that kind of the serialization, etc., is all taken care of as well. And that leads to a higher level of abstraction, and that's something that Cubonacci does. So what is it going to look like in the future? And of course, this is all opinionated from my perspective, but I talk to a lot of companies and a lot of smart people who are working on these problems. I think there's going to be a consolidation towards training and serving under one roof. And the big benefit of that is that a platform can take care of a lot more things in between, because training, you start with experiments with your code, and then doing like training a model, serializing that, storing that somewhere, and then handing it over to something else is a lot more delicate than if you have everything in one place. Deployment, there's going to be much tighter integration with regards to infrastructure, monitoring capabilities, and all kinds of other tools that are important to get to the next level of maturity. And then if you look at like kind of deployment strategies, of course, the initial deployment is maybe just an API, but you can have very intricate deployment strategies with A/B testing, where you use feedback from the downstream system, or shadow running your model, etc. And then maybe automated decision making on top of that feedback to determine, okay, now I'm certain enough that this new version is better, so we're just gonna take away the old one. And I think that's kind of where the future of deployment will be. So are there any questions or remarks about deployment? No?
Maybe I'll rephrase that. Any thoughts, agree, disagree, anything like that? Again, as a workshop, if you guys want to get involved, go for it. All right, keep it rolling.
All right. So the second topic that I want to touch upon is reproducibility. And this is a concept that originates more from the scientific world, but there's a lot of overlap with the needs of reproducibility in science and in practice. But there's also a lot of differences because the goals can be pretty different. First, let's see what is reproducibility. So a definition I found online it says reproducibility is the extent to which consistent results are obtained when an experiment is repeated. So what that means is, if you're gonna redo something, will you get the same results? And this sounds very binary, and preferably you would like to have like 100% reproducibility, but it can be a bit of a sliding scale where maybe you can get very close and that can be good enough, or maybe you have to be precise. So that's reproducibility. And when talking about results in this context, that can be many things. You can talk about the data. So of course, you have some source system of data, and then you extract a training set from that. That source system can be very fluid. So how can, and data is always an input for experiments and for models, etc. So how can you reproduce models if you can't reproduce your data? So that's already a very tricky and important step. And experiments, yeah, you need to be able to trust the evaluations. So not being able to trust your experiments or reproduce them means you can't really trust your system. And then the same with predictions. If you have, if you get a question like, hey, 3 weeks ago we made this decision based on the prediction of this model, but it went horribly, like being able to reproduce exactly what happened means that it's much easier to deal with this kind of situations. So the goals of reproducibility in this context can be boiled down to trust. If you can reproduce everything in your system, it makes it a lot easier to trust. If you reverse that, how can you trust a model if you cannot reproduce it, right? So that's an important part. Diagnosis. So the example that I just gave, like if something goes wrong, like being able to diagnose why that happened makes it a lot easier to solve those kind of issues. In some cases, and especially in the financial world, this happens a lot. By law or by regulations inside the company, it's important to be able to reproduce exactly how you came to a decision, especially if it can impact people's lives, also in healthcare, etc. And another one that's a bit less obvious, but I think that one is also very important, being able to transfer knowledge between like colleagues. If you can reproduce everything, that becomes a lot easier. And that's something that I think you cannot understate, especially in an environment nowadays where people change jobs every year, etc. So being able to reproduce helps kind of handovers and being able to understand what's going on. So if we look at these 3 pillars that I chose from data, so what does it look like? As I mentioned, data snapshots are very tricky to reproduce, and it's because data sets can be very large. The source systems can be somewhat unreliable. There's laws, etc. So I kind of put 3 patterns here. So the ideal scenario is if things are reconstructible. And what that means is that given the configuration or given the parameters that were used at the moment of creating your training set, if those are enough together with the source data to reconstruct the training set exactly, then that's ideal. However, that requires significant constraints on your source system, which sometimes you cannot really control. And there's also challenges with regards to, for example, GDPR, that customers have the right to be forgotten, and then you can never really reconstruct that. That's a challenge by itself already. The other extreme is to save the snapshot itself. And the upside of that is that you're not reliant on the source system anymore, because you create your training set and then you save that and use that for your experiments, and then you can always go back to that one. The big downside of that is, of course, is that it can be very expensive. The storage required to be able to do that, especially if you do this frequently, can be enormous. So that's a big downside. And you can find like a policy that's a bit in between there, where maybe you can choose to save snapshots, or you can just choose to throw them away and only keep the metadata. That does mean it's not reproducible anymore, but you can then have a policy that only models that go to production have to have this snapshot saved. And the third one is if neither of those are possible, maybe because you're dealing with terabytes of data, you can do something that allows you to check if you're able to reconstruct your data set by hashing the data set and storing that hash, and then reconstructing it and seeing if it matches. But then if it doesn't match, then you cannot actually reproduce it anymore. So but this is a very difficult topic, and there are some solutions that are focused on these challenges. You have solutions like DVC. Delta Lake tries to deal with deltas, which allows you to reconstruct things more easily. And things like S3 have some kind of basic versioning in there. But this is a difficult topic, especially for kind of a generalized approach. Then if you're looking at experiments, what kind of things are necessary next to the data? Well, you need the code to train your models, but also to evaluate them. Random number generators can influence the results. So maybe being able to save a seed and use that for all the RNG in your process can help make it reproducible. And actually storing the hyperparameters and of course the results is also important to do that. And then last, for predictions that you're making, you of course need the model. That model has all this like hyperparameters, the data, etc., as inputs. But once you have that model, all you need is the input data to be able to reproduce the output, unless there's some stochastic like influence in your predictions, and then you maybe also need to take care of the seed. So this is a very difficult topic, but it's getting increasingly more important. So how do I think it's going to look like in the future? Well, if you're talking about, yeah, sorry.
And while you're doing that, if you take a look at the chat, Garrett's got a question. Oh. If you just keep that in mind there.
Yeah, I'm not seeing the chat because I don't understand Zoom so well. Ah, here, wait. Chat.
Right. Garrett, if you want to just ask it, you can do that as well. I just I want to make sure it's brought up here.
Yeah, okay, I'll repeat the question. What quantities of data with regards to data snapshots do you consider to be extremely expensive to store? Well, of course, it depends on a lot of factors, but I think if you're talking about like tens or hundreds of terabytes, then it can start become expensive. And it doesn't only matter of how many, like how large are your data sets, but also how frequently are you generating those. Yeah, but and it depends on whether you have if you're running it on premise somewhere or if you're running it in a cloud environment. How fast do you need to be able to access those? How often are you going to access those ones? So it really depends on, it's kind of a trade-off between how important is this for me versus how important is it to store these things. Yeah, but like storage is not too expensive, but transferring data can be expensive, and sometimes you deal with terabytes of data for a single training set, and then of course it becomes prohibitive relatively quickly. So with regards to data snapshots or reproducibility, I think there's going to be more and more purpose-built storage and pipeline solutions, specifically with reproducibility in mind. Immutability is an important topic in there, and I think there's going to be more kind of fragmented parts of the market that are really focused on that. Because if you have immutability, you don't have to store the same data many times if you have multiple data snapshots where there's a lot of overlap. And there are tools. I think Delta Lake has a lot of potential. At the moment, I don't think it fully covers all the challenges there, but I think there's going to be a lot of maturity in that direction. So I think in a few years, there's going to be very good solutions that will help with this. Yeah, experiments are decently covered already. There's going to be further integration, and being able to track more and more things more easily will help kind of just the full lineage and understanding what's going on. And if you're talking about predictions, you kind of have two options there. You can either store the inputs and the corresponding output in the source data system, so whether it's a SQL or some kind of NoSQL database or wherever. Or you could, there's going to be more and more specialized stores to cache or to sync all the inputs in the model and the corresponding outputs with some metadata about which model actually produced that. And things like Elasticsearch are good options for that, but I think there's going to be more specialization in that sense. So that's kind of finishes the reproducibility part. Are there other opinions, questions, suggestions in this topic?
I think you're good.
All right. So then the last topic is automation. And automation is a very kind of broad term. And it can be, yeah, basically anything can be automated in a machine learning system. But it can start with just having, being able to start a process with a single click, right? Instead of doing all those steps manually, being able to kind of start something with a single click is where things can start. You could automate like these things with an API, and then I'm not talking about a model API, but an API for a platform that allows other systems to do things. So you can then have maybe some trigger that there's new data coming in, and then restart model training, things like that. Scheduling workflows, more time-based triggers of different things, whether that's making predictions or retraining your model. That's part of automation. In the software engineering world, more and more is Git-based. So Git is your single source of truth. Triggering things in certain branch policies can automate things. But another type of automation is being able to monitor what's going on with your models and using feedback to maybe automatically alert different stakeholders if things are going wrong. And of course, that will help increase the trust in your system. So why are you interested in automation? First of all, the more things you automate, the easier it becomes to iterate. Because if a lot of these things are manual, whether it's about deploying your models, etc., the more expensive it is to make a change and push that through, which significantly decreases your ability to iterate. And of course, that means it's going to take longer before something gets into production, and you're less likely to make improvements there. It also means that if you automate things properly, and that's going to take a bit of time to do that initially, but that means afterwards there's less human intervention required, which leads to fewer mistakes and a higher trust in your system. And then last, of course, there's going to be changes in the world. I mean, I heard a story from an old colleague of mine. They were retraining the models very frequently, and their model was able to pick up the significant change because of the Corona crisis pretty rapidly. So if you're not automating things, your models can never capture change in the underlying relationship that you're trying to model and that you're trying to automate your decision making on. So being able to adapt to change is a good reason to automate things. So what does it look like now? This is very different per organization, but in a lot of organizations, there's not a lot of automation yet. And that means there's a lot of manual work, which is expensive, fault sensitive, etc. What we do see is that there's a large amount of companies are increasing their automation quite significantly. And that makes sense because of all these reasons that we talked about. And because just as a kind of industry, we're definitely getting more mature with everything related to machine learning, but definitely with automation. But what does happen is that there's a lot of companies and teams kind of reinventing the wheel there. And that's also because there's not a lot of good kind of generalized solutions yet. And so tools that are frequently used for this kind of automation can be things like Airflow, Argo. So Airflow is Python-based DAG toolkit that allows you to define workflows and trigger them in different ways. Argo is somewhat similar, but it's very Kubernetes native. It's actually something that we use internally at Cubonacci to manage a lot of things. And if you look at the future, I think it's going to be more and more essential after you have the basics covered. So maybe having your first model in production and getting your first like value capture. I think automation is an important next step, both because of the kind of stillness of if you only have a single model and you're never updated, but also scaling as a team means that you cannot do too much maintenance of different models that you have running. So automating things and trusting that things will keep working until you get some kind of alert means that it's much easier to scale as a team and capture way more value that way. And integration is also important there. I think there's going to be it's a very complex landscape, and if different parts of the tool ecosystem need to integrate further and further to make automation easier. So I think there's going to be a lot of focus on that. Are there any remarks, questions, experiences, maybe success stories or failure stories with regards to this that people want to share? If not, then we're going to continue. All right, so I kind of summarized things in a few takeaways, and then we're going to go to the next part of the workshop. So the first takeaway is that the field is getting more mature, but there's a lot of room for improvement. And hopefully I showcased a few things where improvements are definitely an option. And because machine learning is getting a more kind of common thing in organizations, it also means more business critical applications are reliant on machine learning models. There's more and more at stake, and this means the level of complexity increases as well, which requires you to kind of deal with these challenges in a better way. And this increase in complexity means that deeper integration is required to be able to handle that. And that can be either end-to-end. So that's the approach that Cubonacci is taking, where basically dealing with multiple of these challenges in one platform allows you to automate or take care of a number of these things more easily. Or if you have multiple solutions that are all kind of specialized in one part, being able to integrate those more easily and more reliably means that this level of complexity is more manageable. So that's kind of the part about my ideas and views on challenges at modern machine learning. Do you have any questions, remarks so far. You maybe, Chris?
Well, so I think that there's no questions kind of from the chat or anything like that. I think that we've been talking about this for quite a while in the MLOps community, and I don't think that anything you've said is either solved completely yet or understood, or not understood, I should say. I don't think anything you said was horribly irreverent in this space. So I'm kind of curious to see the kind of walkthrough and the workshop and kind of how it works. And if you're just joining us, I know there's a few people who've come on late. I'll repost it. What Jan is going to work through in the workshop, you can go into the chat and sign up at Cubonacci. Oh, there it is right there. And you can work through this example with him. So yeah. I think everyone's here and super keen to get that going. So I'd love to see it.
All right. I'll quickly show you what it, oh, that's not the one I want to press. What that kind of process looks like. So after you sign up with your GitHub account, you can create a new project. And you can then add a repository. And then here you can say, okay, I want to allow Cubonacci to access very specific GitHub repositories. So that's what this looks like. Well, in this case, I already did it, so you don't get to see it. But you can read what you're authorizing for. And then here you can choose whether you want to use an existing repository or just allow Cubonacci to create a new one for you. And after you have linked that, then you can do an example, choose an example project, and yeah, we'll commit the first thing for you, which is the example that is fully working already. So you can use that to see what's going on. I already have one here. So this is the German credit workshop. And the reason why we're using GitHub has to do with this reproducibility, because basically any resource that is created when you're dealing with machine learning is related to the code base that is used for this, right? So you have code and you have data, and code can already have an aspect of being able to capture that data or whatever. So code is already always kind of at the root of everything. So that's why we've chosen to have a code first approach where Git is your kind of starting point or your single source of truth there. And as I mentioned before, we have chosen to take this kind of more end-to-end approach where we deal with experiments, deal with the infrastructure, deal with the deployment, parts of the automation steps, etc. And that allows us to take care of, yeah, abstract away a number of these challenges. And if you look at how other kind of end-to-end platforms work, is we have taken a slightly different approach. A lot of these other platforms use some SDK where you can kind of like similar to MLflow, where you can define artifacts or model results and push them to some server. But the choice we have made is to have more of a standardized approach of your code base. And by following that standardized approach, that gives you two advantages. The first is that it allows you to have a standardized way of working together with your colleagues. But the second one is that Cubonacci can reason a bit better about what is happening in your code base. So you can see here, this is the overview of the project. There's only one commit. That's the example project commit. That is also the one that you'll have after starting the example project. And after, yeah, so you can see here, and basically here Cubonacci clones your code and validates that the structure is according to our standards. And we have a notebook environment that is a bit different from most notebook environments because they're connected to commits, and we have an IDE here at the top that basically contains your whole Git repository. But this also allows you to make changes and push them back, but also interact with them directly. So I'm going to use this a little bit for to show what this structure looks like. So here you have your algorithms. This is just an interface that's similar to scikit-learn. So here you have your fit, and your predict method. Here you have some print statements. Yeah, I implemented the optional feature importance, and there's some configuration that explains what the hyperparameter space looks like. Similar to the models, the interface to the data is also code first, and that allows a further level of integration or automation, because even if your underlying data changes, if you can use the same code, that means that we can automatically create new snapshots with newer data in there. So that makes it a lot easier to kind of keep your models up to date. And there's things like metrics, your requirements that you can define here, etc. So this is kind of the code base that we expect. And below here, after you create a notebook, you can choose whether you want to pre-fill it based on the commit. And the nice thing here is that we can use the commit. I'll zoom in a little bit. You can use the commit to import code from, and basically immediately check if differences make sense. So I can say here, and I can just run this again, and you can see that it immediately updates it. So this makes a nice interactive approach. But we're not going to talk too much about the development. I want to just showcase some of the sorry, I need to do prediction. So here there's some basic steps that that you can take and make changes and see if that works. So I can now commit this back. It shows that I changed the data loader, and I'll commit this back to Git. So has everybody started the project? So now you can see the new commit was updated. It's connected here, and we can use that. So here it's validated, and this is kind of your, again, this is your starting point for different operations in the platform. So we can create experiments from here. It's running on top of Kubernetes. This is hosted by us in a cloud environment, but this can also be installed on-premise or in your own cloud environment. And as I mentioned before, we also manage infrastructure for you. So that means that you don't have to think about it if you don't want it. And that's good to mention. The account that you just made, it's free. You can just keep using it for personal projects, small cases, just to play around and learn a bit more. So here you can see, okay, I want to do an experiment. I can choose the instance that I want to run it on. I want to check if there's any snapshots that I can use. So we cache those, as I mentioned before. In this case, that doesn't exist yet, but then we can automatically create a new one. So I will say data snapshot, and I'll make an experiment here. And here you can say, okay, how many trials do I want to do? What kind of suggestion algorithm do I want to use? So I'll say, let's do 8. And it will do 2 at parallel. So here, and this is kind of where this reproducibility comes in, that we talked about a lot. Here you can see this experiment, a lot of metadata about it, right? Like configuration that we used, what snapshot this is based on, the commit that is based on, which algorithm that we're doing. Here are some settings about the machines, but also about kind of the experiment itself, like which metric are we optimizing, what validation schema do we want to use. So you can see here, it took some time to get started. In this case, because it was a new data snapshot that was created here, and here those logs are captured and saved together with all the other metadata. So that means basically having all this data available and later going back and understanding better what happened makes that a lot easier. So now, 1 second. It's going to start the experiment, and this is distributed, so it's going to actually start different pods with different trials at the same time. It takes about a minute to get started. All right, so you can see here, it started 2 trials. On the right here are these hyperparameters. Those hyperparameters were defined in this configuration. And on the left, you actually have the the metrics that you also defined yourself. So you can basically pass on basic scikit-learn metrics, but you can also just define custom ones that align perfectly with kind of your business case. So here you have a nice graph, and then you can also check the individual trials. So with again, their logs are captured. Because we chose to do cross-validation, you can see it's actually being trained 5 times, and you can see what experiment is part of, etc. So this really helps with this reproducibility part. As long as the data snapshot is available, you can always go back to experiments. You can see which commit it was based on. You can restart an experiment, choosing that snapshot with the same settings, and you can do the same thing again. The random number generator part that I talked about is not in there yet, but that's something that's on the roadmap, and that's required for kind of perfect reproducibility. But the stochasticity usually involved means it's not too large of a difference. All right, so it's finished now. That means well, we got a message. We can then use this if we're happy with the results. Of course, usually it will take number of iterations with changes to your code, maybe different feature engineering, etc. But if you're happy, you can choose to then kind of turn this into a full model, and that basically means then that we train a model without taking off any data and serialize that and store that. And that means that if you're going to use that model, deploy that. That means from there on we can again see exactly which steps were taken to be able to get to this model. So here I'm gonna deploy it as an API. I can choose how many replicas I want to use. I'm on a free account here, just like you, so you can only do 1. And that's kind of what this looks like. So here the full lineage is available there. The status, so at this moment none of the replicas are up yet, because it takes a minute or 2, and I didn't use autoscaling. But you can see here, endpoints are kind of, yeah, the way to expose them outside of the platform itself. And we currently didn't connect those. But we've separated those, so you have live, or you have endpoints and you have deployments, and you can then connect them to each other. And as long as the kind of the schemas of your data don't change, that means you can just connect a new deployment to an old endpoint, and the downstream system doesn't even need to know if it's not required that there's a new one. So that allows you to kind of have continuous delivery of new products or models. And there's some this is some telemetry monitoring, and here something that I didn't really touch upon, but to reduce the complexity a bit as well, is if Cubonacci can understand what your data looks like. So if we take a look at our notebook, and so the data loader is responsible for passing the data to Cubonacci, whether that's in memory or together with an iterator stored on the disk somewhere. Cubonacci does some checks to understand what the data looks like. In this case, it's a pandas data frame, so that's very easy for us to understand. And we do that inference basically between getting the data snapshot and then passing it to the model. And that means that we can do things like automatic API contracts. So here you can see we have a form input to test things out. And so let's say this person wants to borrow 2,000 and it's a 21-year-old. We can send a test request. This is the corresponding JSON payload that is being sent to your model. And basically, this is passed through the predict method of the algorithm that you provided. So it's very similar to how scikit-learn is done. And the reason for that is that we believe it's very important to be flexible, but still make things easy. So it's really formed around how a big part of the open source ecosystem looks like. And this prediction part, that part is directly returned from the return object from your predict method. So let's take a look at what an endpoint looks like. So that for this project, we don't have an endpoint yet. But let's say I want to make a live endpoint. I'll connect it to it. And then I can also use code generation for different languages to kind of make a showcase what this call would look like in these different languages. So if we take a look at we don't actually have a lot of time left, but if we take a look at the topics that we talked about, then kind of the lineage or reproducibility is something that we have put a lot of focus on. I hope that it's clear how that works, and I explained the reasons why I think that's very important, and especially in the financial industry, which is I think an industry where a lot of these kind of challenges are more prominent. But we have chosen to do it in a way that it's easy to be flexible, but with this end-to-end approach to manage a lot of the complexity with regards to this, like deployment, with regards to the, how do you say it, the reproducibility, etc., to kind of take care of that for you. Yeah, so are there any questions so far?
Yeah, I want to do a couple things. I want to make sure we've got 10 minutes or 9 minutes left, and leave some time for questions.
Yeah.
And not only questions, but thoughts. I know that Jan this is an ongoing project, and they're working on it, and it's a commercial entity, but always open to suggestions. As well as, I'm curious if you were able to follow along and do it as the workshop. We're trying to look into more workshops and kind of how things go that way. So I'd love to hear everyone's thoughts. That's on the talk right now.
Yeah,
you should have talking permitted.
Hello.
Hi.
Hello.
Hi, Jan. Thanks for the session. I had a question. So just a context, I work as an AI developer, and I develop on item-to-item collaborative filtering recommendation system. And I was quite interested in Cubonacci. So can you, as you already know, recommendation systems are a subjective thing, because not only the metrics matter, but also how you infer those metrics and how a person looks at the results also matter. So can you give some thoughts on how machine learning life cycle management happen in when you develop recommendation systems in an online fashion, like an online machine learning fashion?
Yeah, no, it's recommendation systems are a bit of a different beast from a lot of the other machine learning cases, and it's mostly because when you're training these models, it's usually some kind of proxy task, right? Like, because you don't have historical data of what would have happened if you recommend something. So you're frequently trying to model kind of interest and use that to guide decision making, what to show to somebody, etc. And so what it means is that it's you only really know how well you're doing once you have something live and once it's being used. And so it's very important there to have some feedback loop in there to be able to monitor, either directly or indirectly, how well people are responding to it. So whether it's a click-through rate, maybe it's kind of the time that people are watching a movie that you recommended, those kind of things is essential. And if you want to mature that a little bit further, that means that you basically, once you have a number of models deployed, that you kind of want to automate things surrounding that. But a lot of the concepts that we talked about before, they don't really change. The only thing is that your experiments are kind of indirect evaluation of how well you're doing. So the real test starts when you're actually deploying things. So I think as an organization, and in a lot of organizations, recommender systems are a bit of a kind of a on the side of the organization, because it's maybe for social media or for the website, but in a lot of other cases, it's kind of the core part of the product. In those cases, I think it's really important to set it up in a way that allows you to iterate very fast, to measure everything on how the feedback is from the users, but things like the lineage and proper serialization of your models and being able to track everything, that's very similar to other products. Does that answer your question?
Okay. Yeah, that answers it. Can I ask another question if your time permits? So I was interested in if we can deploy, make deployments of machine learning models in a canary fashion using Cubonacci. Is it something which is possible as of now, or something in the roadmap?
That's something that is, that's something that's on the roadmap. So there's a number of more advanced deployment strategies that we have in the roadmap. So one is canary deployments for either using direct feedback, basically, or metrics, like maybe it's having issues like errors and you don't want to actually run that, but also with the feedback that's coming back. And then kind of like A/B test, but then by gradually just increasing the amount when you're sure that it's doing better. But also A/B testing and things like shadow running your model. So that's not relevant for recommendation systems, but for example, for making sales forecasting. Like a week later, you might know what you actually sold. So you can then use that on the background with a secondary model to see if it would have performed better, and then deploy that automatically. So yeah, that's something, it's a big topic, and that's coming somewhere in the next 6 months. Depends a little bit on the customers that we're talking to, how important it is.
Oh, thanks a lot.
All right, you're welcome. Are there any other questions?
Just if they want more information, can they reach out to you directly, or you're in the MLOps community Slack, or what's the best way to talk?
Yeah, so I'm always in the MLOps community Slack. I'm quite active there, but also you can find me on LinkedIn. I'll share my, I'm very happy to connect. And if you're interested to learn a bit more about Cubonacci, or just how I see certain things that are happening or going to be in the future, I'm always happy to chat. So make sure to reach out and just send me a message. I really like talking about this topic. So yeah, I posted my LinkedIn in the chat.
All right. Well, thank you very much. We appreciate it.
Yeah. All right. Thank you all for being here. And yeah, I'm happy to talk to you further if you're interested.
All right. Have a great day.
All right.
Talk to everyone next Wednesday. Bye-bye.